Alright, this is pre-algebra video, chapter 1, lesson 8 on roots. We're going to talk about square roots and cube roots, and this is what their symbols look like at the top. Now, our objective is, as a student, I can find square roots and cube roots because I'll apply what I know about their opposites, or their inverse operations, which squaring, for example, 3 squared, 3 to the second power equals 9, and cubing, 2 cubed, or 2 to the third power equals 8. We're going to be working backwards in the other direction. And by the way, the calculator is my friend only if necessary. So we're going to start with some brief definitions, some vocabulary. Alright, so first we're going to talk about square roots. The square root of a number is one of its equal factors. In other words, what times itself. So for example, the square root of 25 is 5 because 5 times itself equals 25. The square root of 144 is 12 because 12 times itself, 12 times 12, is 144. So perfect squares are the square of an integer, such as positive 1. We can get that by doing 1 times 1 or negative 1 times negative 1. They'll give us positive 1. 4, we can get the perfect square of 4 by doing 2 times 2 or by doing negative 2 times negative 2. Both those will give us positive 4. Or 36, we can get 36 by doing 6 times 6, 6 squared, or negative 6 squared. And then 64 we can get from doing 8 squared or negative 8 squared. Both of those will give us 64. Now, then you would have your cube root or your perfect cube. A cube root is simply, the cube root of a number is one of its equal 3 factors. In other words, the cube root of 8 is 2 because 2 times 2 times 2 equals 8. And so a perfect cube would be numbers like that. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and so on. Numbers like that. For example, let's say we have, what is the square root of 1.69? Now, some of these might ring a bell because some of these might look like a perfect square. For example, 169 is the perfect square of 13, but we're talking about 1.69. Well, the square root of 1.69 is 1.3. Now, you're not expected to do all these necessarily in your head. On your calculator, you could type in 1.3 on a basic 4-function calculator. You would type in 1.3, and then you would press the square root button, and then that would, I'm sorry, not 1.3, 1.69, and then the square root button, and then that would tell you 1.3. Some of these you might be able to do on your own though without it. Now, I want to make a point that if there had been a negative sign in front of that square root, like let's say it was like this, then that means the square root of 1.69 is 1.3, but that negative out there means we've got to change the sign of whatever the answer was. So the answer was positive 1.3, so now we've got to change the sign of it, so it's negative 1.3. So if you see a negative outside of the square root like that, I emphasize that outside part, then you're good to go. Now, I might as well mention that now, since I just kind of alluded to it. If you have a square root of a negative number, for example, we know the square root of a positive 100. The square root of a positive 100 is 10 squared equals 100, and so does negative 10 squared. They both equal 100 because a negative times a negative is a positive. So on that note, technically that 1.3 we got over there, technically the answer is positive and negative 1.3. It's both. So anyways, over here, square root of 100. If we were to do the square root of 100, we would get 10. So we would say the positive or negative 10 because positive 10 squared is 100, so is negative 10 squared. However, if there was a negative sign in here, square root of a negative, it is impossible to have something times itself and get a negative answer. Think about it. Negative 10 squared means negative times negative. That's a positive. That'll never equal negative 100. The same thing goes for positive 10. It'll never equal negative 100 when you square it. So for that reason, the square root of a negative does not exist. So if you ever had a question that said, what is the square root of a negative number, you would simply say, no real solution. It doesn't exist. And we're not going to get complicated, but in Algebra 2, technically it does, but we're not going to talk about that. So essentially, no real solution. The number isn't real. It's technically imaginary, and that's what you'll talk about in Algebra 2. But like I said, don't worry about that now. You won't need that for a couple of years. So just know that anytime you take the square root of a positive number, it has both a positive and a negative square root, technically. And if there's a negative on the outside, that's okay. That just means your answer, let's just slap a negative in front of it. However, if you have a negative on the inside of the square root, you can't do it at all. There's no real solution if that ever happens. Now let's try this next example. You'll notice it's a fraction. So when you're doing these, it's going to be the same thing, except you can do the top and the bottom almost separately. Like you could ask yourself, what is the square root of 25? The square root of 25 is 5. What is the square root of 64? And that's 8. And just to help you visualize that, if you had 5 over 8 times 5 over 8, meaning 5 over 8, 5 eighths squared, you would still get 25 over 64. So it's kind of like doing the same thing. You can do the top and bottom separate. Now, in this question, we specifically wrote the plus or minus in the front, but that wasn't really necessary. But that's kind of really wanting us to remember that it technically does have a positive and a negative square root when we go to find that answer. They're being kind of picky by asking us, but just being mindful that it's there. Now let's say we were asking for what is the cube root of 216. And by the way, you know it's a cube root because it's denoted by the little 3 right there on the radical sign. Speaking of which, you'll notice these didn't have anything on the left, but technically if there's nothing there, it's implied that it's a 2. It's one of because the radical by default is kind of a square root. There's a 2 there assumed. Alright. Anyways, so cube root of 216. You're asking yourself, what times itself equals 216? Now, it's okay if this takes a little bit of experimenting on your part. I know the basic 4-function calculators don't have a cube root button, but they do have a square root button. So for these, you're going to have to just experiment. Here's what I will tell you. We'll be kind and not make the big scary numbers, like weird decimals and stuff. So experiment. Try things like 4 cubed, 5 cubed, 6 cubed, 7 cubed, until you find one that gives you this. And so if you went through all that process, you would end up finding out that it's going to be 6 cubed would give you 216. So 6 times 6 times 6 equals 216. Now, I feel I should point out that up here, we were not allowed to do the square root, the second root of a negative number. But now look what we have down here. What we can do. You can take an odd root, a cubic root, a third root, a fifth root, a seventh root. Not that we're talking about those higher power ones, but you can take the cube root of a negative number, because think about it. Positive 2 cubed, 2 times 2 times 2, that equals positive 8. But if let's say we had negative 2 cubed, so negative 2 times negative 2 times negative 2, well, a negative times a negative is a positive, but times another negative is a negative. So that would give us the negative 8 that we're looking for. So that means the cubic root of negative 8 is negative 2. And it's only negative 2. It's not positive 2. It's not like over here where we said plus and minus. It is just minus. It is just negative 2. So it only has one. So cubic roots only have one result. So sometimes you're presented with an equation. Now, just like we mentioned in the beginning, squaring something and square rooting something, they're opposites of each other, meaning they undo each other, meaning they cancel each other out. Just like we were talking about before with solving equations in class when reviewing 7th grade stuff, the same thing goes for cubing things and cube rooting things. So let's say you have an equation where 16 over 49 equals x squared, meaning in order to solve for x, in order to finish getting x by itself, we got to get rid of this 2 in order to finish getting x by itself. And in order to get rid of a square, you got to do the opposite. You got to do a square root. So that means we would square root both sides, and then they would end up the square root and the square would cancel on the right side, and on the right side we'd be left with x. Now on the left side, we just need to figure out what that equals, and then we'd use the stuff we talked about before. The square root of 16 is 4. The square root of 49 is 7. So 4 over 7, that's simplified all the way. So that tells us the value of x that would make this true is 4/7. That's how it would look like if you were solving an equation that had a square or a square root in it. Now, if we were cubing, it would still look the same way. So let's say 27 equals z cubed. We got to get z by itself, so we got to get rid of that cubed by doing a cubic root. Now, unfortunately, there isn't a pretty button on the calculator to do this one for us, so you almost have to experiment with this one and kind of guess and check. But here's what I will tell you. For the cube stuff and the cube root stuff, for now, since you only have a basic four-function calculator, they are going to keep it to simple numbers that you should be able to find without too much trial and error. So anyways, the cubic root and the cube cancel out, and on the right side, we're left with just z. Now on the left side, the cube root of 27. So 3 times 3 is 9, times 3 is 27, so the cubic root of 27 is 3. And that's going to be our answer to that equation. So I want you to know it can be used in the equation format. It's that final operation that we hadn't really talked about too much when solving equations. Just like when we talked about adding, subtracting, or the opposites or the inverses of each other, and so are multiplying and dividing. Well, now we know squaring and square rooting are as well. And as a side thought, the same thing goes if it were in the opposite direction. For example, let's say you were to square a square root. Like let's say we had the square of square root of 25, or square root of 25, all that squared. Essentially what would happen is that square root and that square would cancel, and the answer would be 25. So just same thing goes. If you want to get rid of a square root, you could square it. Just like we did up here, to get rid of a square, we took the square root. So I just want to know it works both ways. So now I'm going to give you guys a few examples for you to try. Make sure you get these written down. Alright, so I've written about 5 examples for you to try on your own. I want you to do each of these. So for the first 3, top 2 and the one on the left in the middle row, I want you to go ahead and just find out what that equals. And then for the other 2 that are equations, I want you to solve that equation. Hit pause and give those a shot, then hit play and see how you did. Now, for the first one, we see the negative is on the outside, so the answer to that square root is going to be a positive, but essentially square root, we're going to throw the negative in front. So now the square root of 64 is 8, the square root of 225 is 15, so negative 8 over 15, that's going to be our answer for that first question. Now, go on to the second one. If you haven't done that already, make sure you do. They specifically want us to point out the positive and negative square root. So we're going to say the positive and negative. Well, the square root of 1.44, if you're not sure, 144, 12, maybe use the calculator if you're not sure how to do that with the decimals. It's going to be 1.2, and that's going to be the answer to that question. Now, on to the third one, the cubic root of negative 1,000. Some of you might be thinking, wait, that's an error, we can't do that. But then remember, you can take the cubic root of a negative number, an odd root of a negative number, but you can't take an even root or a square root or a fourth root. You can't do those of a negative, but you can with an odd. If you're not sure why, rewind back to where we talked about it. So it will be a negative number, so we have to figure out what times itself will equal 1,000. And you may have already figured this one out. It's going to be 10. So negative 10 times negative 10 times negative 10, that's going to be negative 1,000. Now onto the equations. If you haven't done those already, please do. And I ask that you be careful and actually show your steps, meaning show me what you do to both sides. For example, on this last slide, you showed me how I showed you how I square rooted both sides, or I cubic rooted both sides, and how they canceled. I want you to actually show that to me and show that to yourself on your notes, so you make sure you know what is that proper step to do. Even though these might be easier questions, let's practice it now when they're easy, so that when it gets harder, we still don't hesitate with how to show our work and be organized. Alright, so to get m by itself, we got to get rid of m squared. In order to get rid of m squared, we square root both sides. So the square root and the square cancel. We're left with m equals, well, the square root of 100, that's positive or negative 10. Both of those squared would give us 100. So we have 2 solutions, positive or negative 10. Now, on to the last example. Square root of z equals 10.5. Well, we got to get rid of that square root. And so the opposite of a square root is a squared. So that means this square root and the squared are going to cancel. Oh, forgot to do it to both sides. Square both sides. So on the left side, we're going to be left with the z. Now on the right side, don't be shy to use your calculator to find out what is 10.5 squared if you're not quite sure. And it's going to give us 110.25. And that's going to be our solution. Z equals 110.25. Alright guys, so we've now done examples of talking about what does it mean to square or square root something, cubing, cube rooting stuff, and then you also solving equations a little bit with those operations in them. So make sure you have all this written down, rewind, rewatch what you need to, and make sure you come to class prepared. And let's take this even further.